सो हेलो स्टूडेंट्स, ये जो टॉपिक है ये यूनिट 3 का टॉपिक है एंड यूनिट 3 के ऊपर जो थोड़ा थोड़ा ट्रिकी कॉन्सेप्ट है वो कॉन्सेप्ट मैं इस टॉपिक में डिस्कस करने जा रहा हूँ। और ये जो यूनिट 3 के अंदर जो जूल्स एक्सपेरिमेंट है, जूल्स मतलब जूल्स एक्सपेंशन, फ्री एक्सपेंशन है, फ्री एक्सपेंशन। तो डिफरेंट टाइप्स ऑफ गैस अगर फ्री एक्सपेंशन करना चाहे तो क्या होगा, डिफरेंट पैरामीटर का वैल्यू क्या चेंज होगा, ये सब मेरा इस डिस्कशन के अंदर है। ठीक है, तो चलो दोस्तों शुरू करने जा रहा हूँ। सो फ्री एक्सपेंशन, तो फ्री एक्सपेंशन क्या होता है? सो लेट अस कंसीडर एनी टाइप ऑफ गैस दैट विल कॉन्फाइंड विद इन ए सिलेंडर पिस्टन सिस्टम। ठीक है, सो let us consider any type of gas that will be confined within a cylinder piston system. So there it is your cylinder piston system, and within that cylinder piston system there will be a gas. Okay, so this gas, there are different kinds of gas. Either it will be an ideal gas, or it will be a van der Waals gas, or it will be a gas just like having an equation of P into V minus NB is equal to nRT, or P plus AN square by V square into V is equal to nRT. So there are different types of gas, and the pressure of the gas, it will be PI, VI and TI. PI, VI and TI. Okay, and now the external pressure here, it will be P external is equal to 0. So what will happen here? So the gas molecule, it will exert a pressure over that piston. Okay, and due to that pressure, the gas present within the cylinder piston system, it will be expanded under zero external pressure. So from the definition of work, that means the finite magnitude of work, it will be minus integration initial volume to final volume into P external into dV. Okay, and as the gas expand under zero external pressure or under vacuum, so it will be a 0. So the value of W, it will be 0. Okay, and if we consider, and you can say that the infinitesimal amount of work, that will be dW is equal to minus P external dV. So you can write that it will be d cut W, because in order to express the path function you have to use d cut, and in case of state function usually you can use d, only infinitesimal. In order to express infinitesimal amount you simply use d, but if the function is the path function, then in order to express the infinitesimal process you have to use d cut. So if the external pressure is 0, the magnitude of d cut W, it will be 0. Hence, from the first law of thermodynamics, dE is equal to d cut Q plus d cut W, where d cut is used in order to express infinitesimal change of the two path function Q and W. So as d cut W, the magnitude of d cut W is equal to 0, we can say that dE is equal to d cut W. So the change of a state function, the infinitesimal change of a state function is equal to infinitesimal change of a path function. Okay, whereas if you ये जो एक्सप्रेशन आया है, इस एक्सप्रेशन को आप फाइनाइट चेंज के ऊपर भी बेस करके लिख सकते हो। कैसे लिख सकते हो? अगर आप इधर इंटीग्रेशन करो तो इंटीग्रेशन so it is a state function, so the integration limit will be initial internal energy to final internal energy, whereas it will be a path function, so the limit will be 0 to Q. Hence we can say that del E is equal to E final minus E initial is equal to, it is nothing but finite amount of heat. So now if we consider the gas is ideal one, if we consider the gas is ideal one, so we can write del E is equal to NCV bar T final minus T initial. Otherwise we can say E is equal to a function of T comma V. So from the partial differentiation Euler's rule, dE is equal to, we can say del E del T at constant V dt plus del E del V at constant T dV. So if we put the infinitesimal amount of change of internal energy in that expression 1, we can say del E del T at constant V into dt plus del E del V at constant T of dV is equal to, it is nothing but dq cut, and we all know that the magnitude of del E del Vt, for ideal gas, it will be 0. And where it is comes from, it will be comes from Joule's experiment. del E del Vt 0. पर अगर आपको जूल एक्सपेरिमेंट अगर ना याद रखना हो तो आप सिर्फ याद रखना क्या, थर्मोडायनामिक इक्वेशन ऑफ स्टेट। तो थर्मोडायनामिक इक्वेशन ऑफ स्टेट्स का जो डेरिवेशन है वो तो यूनिट 4 में है। यूनिट 4 में जो सेकेंड लॉ ऑफ थर्मोडायनामिक्स है वो तो सेकेंड लॉ ऑफ थर्मोडायनामिक्स के अंदर आएगा, पर इसका जो एप्लीकेशन है वो बहुत बहुत ज्यादा है। इसीलिए यू हैव टू kept in mind there are two equation, so there are two equation. So what's are the equation here? P plus del E del V at constant T is equal to T into del P del TV. So this is the first equation, and another one equation will be del H del P at constant T is equal to V minus T into del V del T at constant P. So there are two fundamental equations, there are two thermodynamic equation of state. So if we apply the first expression, so we can find out del E del Vt for different types of gas, del E del Vt for different types of gas. So let us find out what will be the value of del E del Vt for different kinds of gas. First of all, this del E del Vt, it will be denoted by pi t. So what does it mean by pi t? It means internal pressure. So what is the unit of it? That will the numerator, there will be an infinitesimal change of internal energy. What is the unit of it? That will be joule. And in the denominator, that will be dV, the infinitesimal of change of volume. So it has the unit of meter cube. So if we segregate that two units, so joule is represented by Newton meter divided by meter cube. So it is nothing but Newton per meter square. So the del E del Vt, it will be represented by internal pressure. And what is the definition of del E del Vt or internal pressure? It will be the change, infinitesimal change of internal energy per unit change of volume at a fixed temperature. So it is represented by del E del Vt. Now we have to find out what is the magnitude of del E del Vt for different kinds of gas. It is nothing but, let us consider first the ideal gas. Case 1, it will be the ideal gas. So there are different option will be there. So there will be a question that has to be specified. A question इधर दे सकता है कि you have to find out the internal pressure or del E del Vt for an ideal gas. So there are 4 kinds of options: 0, positive, negative, and etc. So you have to find out the del E del Vt Vt for different kinds of gas. And what is the procedure here? The procedure will be you have to kept in mind that types of first thermodynamic equation of state. So if you put there the first thermodynamic equation of state del E del Vt, it is nothing but T into del P del T at constant V minus P here. Okay. So let us consider in case 1 the gas will be the ideal gas. The gas will be the ideal gas. Oh, del E del Vt, it is nothing but it will be also be pi T. It is represented by pi T. So in case of ideal gas, P is nothing but nRT by V. So if we differentiate P with respect to T at constant V, we can find out del P del T at constant V is equal to nR by V. So if we put the magnitude of del P del T V in the above expression, it is nothing but pi T is equal to del E del V at constant T is equal to nRT by V minus P. So it will be 0. So the option will be 0. So the internal energy change, infinitesimal change of internal energy per unit change of volume at a fixed temperature, it will be 0, and the internal pressure will be 0 for ideal gas. Okay. So if there are 4 options, you will have to specify the correct option will be 0. Now the case 2, what will be the case 2? Now the gas will be the different gas. So case 2, so the P into V minus Nb is equal to nRT. So P is nothing but nRT by V minus Nb. So if you differentiate this, that is del P del T at constant V, it is nothing but nR by V minus Nb. So if you put the magnitude of magnitude of del P del T V in the first thermodynamic equation of state, you will get pi T, it means del E del V at constant T, del E del V at constant T, it is nothing but nRT by V minus Nb minus P, and we know that nRT by V minus Nb, it is nothing but it is P. So P minus P is equal to 0. So pi T, that is del E del Vt, is equal to 0. So there are 2 types of gas, that is first one is ideal gas and the second one is P into V minus Nb is equal to nRT, where the intermolecular force of attraction term, that is A term, is it is not present here. So if the gas does not have any intermolecular force of attraction value, so you will surely obtain the internal pressure or del E del Vt has the value of 0. Okay. So with increment or with the change of volume at a constant temperature, there will be no change of internal energy. So there are next type of gas, it will be the van der Waals gas. So first of all, in case of case 3 is the van der Waals gas. So before we just jump into van der Waals gas, there are another types of gas, that will be V plus An square by V square into V is equal to nRT. So from that expression we can surely obtain the expression of P, that is nRT by V minus An square by V square. So the magnitude of del P del T at constant V is nothing but nR by V, because here the second term, that will be A n square by V square, where all are constant here. So del P del T V is equal to nR by V. So if we put that expression in the first equation of the thermodynamic equation of thermodynamics, so you will get pi T is equal to del E del V at constant T is equal to nRT by V माइनस पी, तो ये क्या हो गया दोस्तों, एन आर टी बाई वी माइनस पी. सो एन आर टी बाई वी माइनस पी मीन्स ए एन स्क्वायर बाई वी स्क्वायर, ए एन स्क्वायर बाई वी स्क्वायर. सो it means the internal pressure, or at a constant temperature, if we increase the volume for this type of gas, the internal energy that will be increases, because a n square by v square, both the terms are positive here, okay. So then the next type of gas, it will be, the last one is van der Waal gas, where both the pressure correction factor and volume correction factor, means pressure A term and B term, both are present there. So as both term A and B are present there, we can say what is the magnitude of pi t. So before discussion of pi t, we have to first find out the magnitude of del P del TV. So what is the expression of van der Waal gas? The expression will be P plus A n square by V square into V minus NB is equal to nRT. So what is the expression of P? P, it is nothing but nRT by V minus NB minus A n square by V square. So what is the expression of that? Del P del T at constant V is equal to nr by V minus NB, So if we put the magnitude of del P del T V in the first equation of thermodynamic equation of state, so you will get pi t is nothing but del E del Vt, is equal to nRT by V minus NB minus P. Again it will be comes out to n square by V square, which is positive quantity, So after analyzing all the available expression that will be presented in the board as case 1, case 2, case 3, case 4. So one thing, it is very much seen from the panel, that if the gas does not have any type of A factor, if the gas does not consider any type of A factor or pressure correction factor, just like ideal gas or just like P into V minus NB is equal to nRT, it means there will be no intermolecular force of attraction term that will present within the gas. Hence we can obtain del E del Vt, or the pi t, that is the internal pressure, that will be equal to 0. So what does it mean here? It means here there will be no type of internal pressure. Internal pressure kahan se aata hai? It will arising from intermolecular force of attraction that will present within the molecule. So if the gas molecule does not contain any pressure correction factor, or there will be no intermolecular force of attraction, then what will happen? Then internal pressure will be 0. But if the gas contain A factor, either the volume correction factor present or not, either the volume correction factor present in the expression or not, if the gas consider A factor, अगर gas molecule का जो expression है, gaseous equation of state का अगर जो expression है, अगर उसके अंदर A रहा, उसका मतलब there will be some intermolecular force of attraction that will present within the gas, and in that case the internal pressure or the expression of del E del Vt, it will be a positive part, it will be a पॉजिटिव वन, और अगर ये पॉजिटिव हो गया तो इसका मतलब है एट ए कांस्टेंट टेम्परेचर अगर मैंने वॉल्यूम को इंक्रीज किया तो इंटरनल एनर्जी डेफिनेटली इट विल बी इंक्रीजेस. सो देयर आर डिफरेंट टाइप्स ऑफ जो एमसीक्यू क्वेश्चन है, डिफरेंट टाइप्स ऑफ एमसीक्यू क्वेश्चन यहाँ से आ सकता है. कैसे ना डेली डेल वीटी का वैल्यू निकालने के लिए दे सकता है, पाई टी का वैल्यू निकालने के लिए दे सकता है, वेयर एज द गैस इक्वेशन ऑफ स्टेट दैट विल बी गिवन इन योर क्वेश्चन, एंड देयर आर 4 टाइप्स ऑफ ऑप्शन, आइदर it will be an square by v square, it will be minus an square by v square, either it will be 0. So there are different types of option and different types of question that can appear from that section also. सो यहाँ से मुझे क्या पढ़ना पड़ेगा, यहाँ से मुझे पढ़ना पड़ेगा अगर जो डिफरेंट टाइप्स ऑफ गैस इक्वेशन है वहाँ से मुझे डेल पी डेल टी भी निकालना पड़ेगा, और डेल पी डेल टी भी निकालने के बाद जो थर्मोडायनामिक इक्वेशन, फर्स्ट थर्मोडायनामिक इक्वेशन ऑफ स्टेट है उसे मैं वहाँ पर मुझे बिठाना पड़ेगा। तो उसे वहाँ पर बिठाने के बाद जो देयर आर डिफरेंट टाइप्स ऑफ ऑप्शन है उस ऑप्शन के साथ मिलाना पड़ेगा। तो चलो ये तो फर्स्ट वाला सेक्शन हो गया। जो सेकेंड वाला सेक्शन है उसके अंदर जो एक्सप्रेशन है, ये एक्सप्रेशन मैंने कहां यूज करूंगा, जो फ्री एक्सपेंशन हो रहा है उस फ्री एक्सपेंशन के अंदर मैं यूज करूंगा। ठीक है।